Hi everybody. I have some examples here of simplifying exponents, which seems to always give students a lot of trouble. The properties that we're going to use, I'll write them to the side here. You've learned these in class, hopefully. If you have x, I'll just put a little example of each. So if you have x squared times x to the third, you add the exponents, so you end up with x to the fifth. Now that's different than if you have x squared raised to the third. If you have two powers but not another x written, then you multiply the powers. So that's x to the sixth. And then with division, like if I had x to the eighth, let's say, divided by x to the second, that is not x to the fourth. You don't divide the exponents, you subtract them. So that would be x to the sixth. One little trick that I tell students is that whatever operation is happening, like multiplication, you do not do that same operation to the exponents. So if there's multiplication, you are not going to multiply the exponents. If this is being raised to a power, you're not going to do 2 to the third power. It's 2 times 3. And then same thing here. This is division. You're not going to divide 8 by 2. You subtract. And then just a couple other ones to tag on here, like if I have x to the negative third, a negative power means that you put the base, which is x, in the denominator and make it a positive. That also works like if I have 1 over something that's negative, like 1 over x to the negative second. That becomes x to the second on top over 1, which means we could just write x to the second. And then there's also, if you have x to the 0, or anything to the 0 power, that just equals 1. I don't think I put any of those in these examples, but let's get started on these harder examples and just show you how this all works with a real problem. So in number 1, when you have a parenthesis and a power on the outside, the power will distribute to every term, everything in here. And so what I will get is 2 raised to the third. Then this is an example of this property over here happening. So the x, we multiply the 3 times 3, so that's x to the 9. The y, we multiply negative 2 times 3, so that's y to the negative 6. And we multiply again for w, so that's w to the 12. All right, now I can actually write down what 2 to the third is. It's 8. And then we have x to the 9th. Now this y, since it's to a negative exponent, I'm going to make a fraction and put the y to the positive 6th power on the bottom. And then the w, that just is going to stay on the top because it had a positive 12. So that would be the final answer for this problem. Now in number 2, I'm kind of adding on, like making the difficulty a little harder with each problem. We still have to distribute the outside powers to everything first. So that 2 is going to go to all of those, and same thing in this parenthesis. And then I'll have a whole bunch of multiplying to do after that. So if I do all the distributing, I will have 3 squared, x to the negative 2, because I'm multiplying all the powers again, y to the 10, w to the negative 4, times, and you can just put the times dot, and then distribute, so 2 squared, x to the negative 12, I'm multiplying those powers, y to the 6th, w to the negative 4. Okay, now I'm ready to do the actual multiplication. Well, with the numbers, the 3 squared and the 2 squared, we know that that's just a 9 and a 4. So I can multiply 9 times 4 together, and that will give me 36. All right, now with the x's, I just kind of go through and find each thing that's the same base. The x is called the base. I'm going to add the powers. So that's going to be x to the negative 14th. I'm going to do the same thing with the y's. So 10 plus 6 adds up to 16. Same idea with the w's. So the -4 plus -4 is -8. So I have that now. And now I can put the negative powers in the denominator. So the number 36 does not belong to the x. A lot of times students put the 36 in the bottom with the x to the 14th. That doesn't happen. 36 is its own thing. And then x to the positive 14 goes on the bottom. Y to the 16 stays where it is because it's positive exponent. And w to the 8th would go on the bottom since it had a negative exponent. Okay, and that's that answer. Now let's take a look at the second page. In number 3, I have division. So what I like to do with the division problems is go ahead and write the division line. Just get it all set up for where you're going to put things. Now the first step, 10 over 4, that doesn't divide evenly, but it does reduce to 5 over 2. So let's do that. All right, now x to the 8th over x to the -2, we subtract exponents. Now I'm going to write this in the margin. We're going to subtract 8 and -2, so it's going to be 8 minus -2, which that becomes 8 plus +2. So that's actually a total of 10. So many times students forget that it's a minus a negative, and they just think it's 8 minus 2 is 6. So don't do that. So it's going to be x to the 10th. Now every time you subtract exponents, automatically put the answer that you get in the numerator, in the top. So x to the 10th goes up there. Then here, this is for the x's. I'll kind of make a little table. And then for the y's, it's -3 minus 7, and that is -10. Now don't worry about the negative, just stick it automatically in the top. Y to the -10. And then let's make a little chart for the w. -9 minus -4 is -9 plus 4, which is -5. And again, don't worry about the negative, just stick it up there. W to the -5. But now we do have to worry about the negatives. So anything that was a negative exponent will switch places. The 5 and the 2, those stay put. X to the 10th stays put. Y to the 10th will go on the bottom now. And W to the 5th will go on the bottom. And by putting them on the bottom, it gets rid of their negative exponent. So that would be that answer. Now in number 4, I have division, but I also have this outside power, which normally you would just go ahead and start distributing it, but I'm noticing that it's a negative. What you could do in that situation first is flip everything on the inside. So basically I'm going to flip all of that stuff with all of that stuff. And by doing that, I can make it just to the second power on the outside. I changed it from a negative power to a positive power. So this is what I get. Nothing on the inside is changing, it's just changing places. Okay, so the numerator became the denominator, and I'll do a different color. The denominator became the numerator. They just literally switched places, and I changed this 2 to a positive 2. So now I do the problem like I did the ones on the other side. You distribute this outside power to everything. Everything on the top, everything on the bottom. So I won't write all those arrows, but it's 2 squared. X would be to the 12th because you're multiplying the exponents. Y would be to the 6th. So when you distribute the power, you're multiplying the exponents. Then I get 3 squared, x to the -8th, y to the 4th. Okay, now it's a division problem. So 2 squared is 4. Let's write the division line like I said before. And then 3 squared on the bottom is 9. Now I get to subtract exponents. So for the x's, you don't have to always write this work, but just so you guys can see what I'm doing, I do 12 minus -8. Which is a total of 20 because it comes it becomes plus a positive. So automatically put that on top, x to the 20. And then the y's are a little easier, this problem, because it's just 6 minus 4, which is 2. So that's y to the 2. And there's no negative exponents, so we get to just circle our answer. I always wait until the very end to move negative exponents around, because if you start moving them around at the beginning, it might be pointless, because like you just saw in this answer, there's no negatives left at the end anyway. So we never had to do a whole bunch of switching, except for that one beginning step where I switched the outside -2 power. Okay, so now for our last problem. I just made a little more room for it here. Now we have everything in this problem basically. So the first thing is that this outside power is negative. So like I did in number 4, I'm going to flip this whole fraction. 2x to the negative 9 y goes on top. 5x to the negative 11 y squared goes on bottom. And then that makes this just a positive squared power. And then I just will recopy this whole other fraction. Nothing yet is going to change in that. Now I distribute these outside powers. So I'm going to go through and do all that. I'll have 2 squared, x to the negative 18th, because you're multiplying, y to the second, 5 to the second, x to the negative 22, y to the fourth. Do the same thing on this other fraction. The outside power is also a squared, so 2 squared, x to the 6th, y to the negative 12, over x to the 14th, y to the negative 20th. Now what I would do is multiply straight across everything in the numerator, like that, and then everything in the denominator. All right, so I have a 2 squared, which is 4, and another 2 squared, which of course is 4. So that's 4 times 4 gives me 16 for the coefficient. Now with my x's on top, I'm adding negative 18 plus 6, that's negative 12. And with the y's, I'm adding their exponents. 2 plus negative 12 is negative 10. And then the bottom, same thing, I have a 5 squared down here, that's 25. And there's no number in the other denominator, so I just have 25. The x's, I'm adding negative 22 plus 14, which is negative 8. And with the y's, I'm adding 4 plus negative 20, which is negative 16. Now I'm ready to do the division step, so I set up my division line. 16 over 25 doesn't divide and it doesn't reduce, so I just get to write those back. Then I'll show the work for the x's. I'm going to subtract negative 12 minus negative 8, which is negative 12 plus 8, which is negative 4. So the x is to the negative 4. And then with the y's, I'm subtracting negative 10 minus negative 16, which is negative 10 plus 16, which is 6. So I get y to the 6th. And then the final step is to notice that the x has a negative. So let's set up the division line. 16 over 25 stays put. X to the positive 4 will go on the bottom, and then y to the positive 6 stays on top. And that is our answer. And one last thing, just mention, like if something doesn't have an exponent, like that, and it's in parentheses, and let's say there's a cubed on the outside, if it doesn't have an exponent, it has a 1. They just don't write that. So that's just 1 times 3, which is y to the third. And like you saw, none of mine had any 0 powers, but let me put one other special note here. Like if I had y to the negative 4th over y to the negative 4th, when I subtract negative 4 minus negative 4, I get y to the 0, and that would just equal 1 if that ever happened to you. And that's it. I really hope that these help you to keep these kinds of problems organized and doable.